Hello, everyone. Today we're going to be performing function operations and also performing compositions. So before we get into that, if you could pause your video and please try the problem at the top of the page. Okay, final answer. You should have got h of negative 2 equals 2. For this particular problem, we're just reviewing function notation. And so for example, whenever you see a number in parentheses next to that variable, that just means that's saying that's the number you're plugging in to that specific function. So if h of x is defined to be 3x squared minus 10, then all it means to find h of negative 2 is plug in negative 2 anywhere you see an x in the problem and solve. So the x that's over here, this always stays. This h of negative 2, remember, that just is the name of the function in a way. So all you're really doing is plugging x in on the right-hand side and simplifying the right-hand side. So negative 2 squared ends up being 4. 3 times 4 is 12, and 12 minus 10 ends up being 2. So your final answer then ends up being h of negative 2 equals 2. So when it comes to the kind of the main theme for today, which is all about compositions and function notation in general and function operations. But before we get into compositions, we just want to get kind of used to working with different types of functions. So I'm going to come back to the vocabulary part of this. We'll fill that in just a moment. But if you look at the first section where it says add, subtract, multiply, and divide functions, this is probably exactly what you're thinking. If I look at my first example, number one, it says we're supposed to take the f function and add it to the g function. And that simply just means we're going to take whatever f of x is and add it to whatever g of x is. So for this problem, I'm going to zoom in a little bit, but if f is the function 4x cubed, g is the function negative 9x cubed, then my goal on this next step is to add those two functions together. Take f of x, which is 4x cubed, and I'm going to add that to whatever g of x is. Now, g of x technically is a negative, so not squared. Since that's a negative 9, when we add a negative here at this step, adding a negative is really the same thing as subtracting. So all we have to do is simplify. 4x cubes, I'm taking away 9. That is going to leave us with negative 5x cubed. That is f of x plus g of x. Now, these aren't called compositions. These are just called function. These are function operations. Just like any operations, when we're adding operations together, it's the main operations: add, subtract, multiply, and divide. So just like we would with addition, part two, where it says f of x minus g of x, we're going to do the same thing, except for we're going to subtract those two things. So 4 cubed minus negative 9x cubed. Ah, not x, negative 9x cubed. Now here, when I subtract a negative, that's the same thing as technically addition. So 4x cubes, adding 9x cubes to that, those are like terms because they have same variable, same exponents. So we add their coefficients and we're left with 13x cubes. Multiplication, exactly this same kind of process you would do with normal multiplication. Take 4x cubed, but here we're going to multiply it by 9x cubed. So here, we're going to multiply my numbers together. 4 times negative 9 is going to be negative 36. Now, just be careful with multiplication and division. The variables don't act the same way when you add and subtract. Adding and subtracting, as long as you have the same variable, same exponents, we add the numbers in front. Multiplying 4x, if I have an x cubed times an x cubed, here we need to use our exponent properties. And total, if I have 3x cubes here multiplied by 3 more here, we have 6 total. So multiplying, we add the exponents, as you can probably imagine in number 4. If we're going to divide our functions, we're going to have to subtract our exponents. But I want you guys to pause your video and I want you guys to give number 4 a shot. Figure out what f of x divided by g of x and try and make sure you simplify. So give this one a try. All right, you should have got -4 9 as your final answer. Reason being is because when I take f of x, which is 4x cubed, and I divide it by g of x, which is -9x cubed, here my variables actually end up canceling. I have 3x cubes on top, I have 3 on the bottom. So we subtract those exponents and we just have 0 of them anymore. So they cancel out. X cubed divided by x cubed cancels, and we're left with 4 over -9. Now, for all of these, I did kind of ignore one sentence, and that is in the directions it says, find the domain. Now, domain, we're going to get into a little bit more once we reach some more complicated functions. But domain simply kind of looks for where the x is and what you're allowed to plug in. So remember, domain, it represents all the x values you're allowed to plug in. So here I can take an x and in question number 1. Let's get rid of some of this there. In example number 1 here, where it says -5x cubed, here, what value am I not allowed to plug into that x? Well, none of them. You can take any number, cube it, and multiply it by -5. For domain, it's almost easier to talk about what you're not allowed to plug in. And all of these, there isn't something you're not allowed to plug in. Something you're not allowed to plug in would be something, for example, where you had an x on the denominator. Because in rational function world, you're not allowed to divide by 0. But since none of these have a denominator, none of these, if they're square roots have kind of a limited domain, and we'll get into that in a little bit, obviously. But for all of these functions, if I say, what is the domain? The domain is all real numbers. You can plug in anything under the sun into those x values, and there's nothing you can't raise to a power and multiply by a number. Okay. Now let's get into the kind of the fun part for today, which is compositions of functions. Now, compositions of functions, I'm going to go back up to the vocabulary section for just a moment. So here, when we talk about compositions, so composition, this one, it's almost easier to talk about in the form of an example, but basically the gist when all things it boils down to is means you're going to take one function and you're going to plug something into that function, and whatever you get out, you're going to plug in to the other function. Now, that's not the only way to do compositions, but so this is how the notation works. So if you see, so usually composition of function can be written one of two ways. The first one is going to look, first of all, has a set of parentheses. So whatever two functions you're involving, let's say those two functions in this case are f and g. Oops, that's not the notation, but let's just say those are our two functions. So how you'll know that I'm asking you for a composition is it'll say, for example, f, then we have this little open circle in between, and G is written after it. And then in a set of other parentheses right after all that, you'll see an X. This right here, that little open dot right here, this is letting you know, that tells you that it's asking you for a composition and that we're going to do something a little more specific. A lot of students, when we get going, think that that means multiplication because it looks like just like a little dot and it looks like you're multiplying, but you're not. That literally means f of g of x. That's what when we say find a composition, that's what you're going to look for. Now you don't know what that means yet, but that's what it's going to ask you to do. So there is one other way you could see a function written, and that's where you would have an f, a parenthesis, a g, another parenthesis, another parenthesis, x, and close both parentheses. These are kind of like the two ways. This is way number 1, and this is way number 2, that I could ask you to perform a composition. Now, what is a composition? So a composition kind of starts off pretty similarly to just to polynomial operations, except for we do something entirely different with it. So here we still have to define what they are. Here in our example number 5 through 7, we're saying f of x equals 2x minus 7, and g of x equals x squared plus 4. So when we look down at that piece, what it's essentially asking us. So for example, this one, they're using the second type of notation. So how this is read, it says f of g of x. And what this literally is telling us, plug, it's always plug in this form, the inside function. If it was kind of the second form, it would be the letter listed second. If it was written the first way, this one's not, but here it basically means plug G into F is what a composition is asking you to do. So everything that G of X is equal to, you're going to plug in anywhere there's an X in function F. So this is what it looks like. We start with the notation. So we start with our first function. So f of x, I'm just going to write it down so I don't have to keep scrolling over. 2x minus 7. So if that's my function, what it's going to ask us to do is we're going to take our second function, which is g of x. Ooh, that was fun. So we're going to take all of g of x, and that's going to get plugged in for x in the actual function. So then let's look and see what f of x is equal to, or excuse me, g of x. So g of x is equal to x squared plus 4. So if we're going to plug in g of x in place of x, g of x is equal to x squared plus 4. So that is what's going to go in its place of the x variable in the f function. So really what this is asking you for when we say compositions, it's basically substitution. It's saying take whatever the inside function is. So in this case, it's g of x, and substitute it in for x or any variable that's in the outside function. And then we just simplify. Usually we'll go ahead and we'll clean it up a little bit. So in this regard, we're going to say take f of g of x. Notation stays. And we just simplify. So I'm going to distribute the 2 that's out in front. We're left with 2x squared, woo, plus 8. Bring down the minus 7. And then last but not least, bring everything else down. And that's going to be equal to 2x squared. 8 minus 7 is going to end up being a positive 1. And I can't simplify anything else. All my like terms are combined. We are done. That is f of g of x. That's our composition. Now, if we switch things up, it just means the exact opposite. So g of f of x literally means we're going to do the opposite. Ooh, it means we're going to plug f into g. So my g of x, my g function is equal to x squared plus 4. And I'm just getting that from over here. I just don't want to keep scrolling. But if that is my g of x function, then to find g of f of x, that means up here, this x that's in there, I'm going to replace any variables with our f of x, what f of x is equal to. So since f of x is equal to 2x minus 7, that is going to go in its place. And then we simplify. So let's go ahead and I'm just going to copy this so we don't have to keep writing this. I know. That's kind of the bad thing about notation wise for this. You kind of have to keep your different values here. Okay. So next up, let's see. I see we have this quantity here squared. So I'm going to multiply that out. That means 2x minus 7. Anytime you have a quantity out and quantity being squared, remember you have to actually physically multiply all that out. So let's see, 2x times 2x, that's going to be a 4x squared. 2x times negative 7 is going to be a negative 14x. Moving on to the 7, negative 7 times 2 is going to be negative 14x. And negative 7 times negative 7 is going to be a positive 49. Bring down the 4 that's on the outside. And now let's just combine our like terms. We have 4x squareds. There's no other x squareds in this problem. My x terms, we have negative 14x minus 14x. That's going to be negative 28x. And last but not least, we have our last two terms, 49 plus 4, which is going to end up being 53. And that can't simplify anymore. That is your function. Now, sometimes you'll reach some problems where you can actually physically go ahead and evaluate it. So here, if I have f of g of 4, this you can do the same thing, except for you can simplify things just a little bit more. So f of g of 4 still just means take g. Ooh, wow, sorry, my pen died. It just means take g and plug it into f. But here, it just means we can actually find out what the actual number is rather than taking the whole function in. So here, what's ever on side, if you have a number, it becomes a little bit easier. Here, I can actually find g of 4 because my g of x function, that's going to be x squared plus 4. So here I can actually evaluate it. Let's plug in 4 in for x. And let's see, g of 4. 4 times 4 is going to be 16, plus 4 is going to be 20. So if I know g of 4 is 20, then when we go to do our composition, so if I'm going to find f of g of 4, that just means we're technically plugging g of whatever g of 4 is, which we found to be 20, in to any variable showing up in the f function. So if my f function is 2x minus 7, anywhere there's an x, I'm going to take whatever g of 4 is, so 20, and that's going to get plugged in. And then as always, we simplify. Woo! G of 4. So if we're going to finish calculating f of g of 4, 2 times 2 is 4, minus 7, or excuse me, 2 times 20 is 60. 2 times 20 is 40. A lot of numbers. 2 times 20 is definitely 40. I'm losing it, guys. 2 times 20 is 40, minus 7 is going to end up being 33. There we go. We got it eventually, right? So if you have your number, if you know what number you're plugging in, you can kind of do that one of two ways. You could do it kind of the way that we did it here, or you could actually go ahead and find the function and plug that in, if that's what plug 4 in for your x variable in that function, and that will work as well, which is kind of cool. So all I have on the next page, if you turn here, I just have some practice problems, which are the same as above. Just remember that it's just written kind of in the other way. So you can either write it as like option number 2, which is what we were just working with, or you'll see it looking kind of like this with either with these brackets or parentheses. You'll also see it as. So here, this still tells me I'm going to find f of g of x. So when you see it in this notation, it just means the second gets plugged into the first. So really, this just means the exact same thing as we're going to find f of g of x. So I'm going to take whatever g is, and I'm going to plug it into my f function. So f is equal to 3x plus 4. And g of x is equal to 2x minus 5. So our goal right now is to take whatever g of x is, which like we said was 2x minus 5, and that's going to get plugged in. You don't have to write it there. Usually we'll just write the second function. So I'm going to take g of x, 2x minus 5, and I'm going to plug that in to our function. And away we go. So if I'm going to find f of g of x, we're going to distribute that 3. 3 times 2 is going to be 6x. 3 times negative 5 is going to be negative 15. And final answer. Bring down the 6x. There are no other variables, terms. And negative 15 plus 4 is going to be negative 11. So I just found f of g of x. What I want you guys to do now is I want you guys to try number 9 and number 10. So pause your video now and give them a shot. All right, answers are up. If you look at number 9, Number 9, you should see here that it says find g of f of x, which basically just means you're going to plug the f function into the g function. So g in this case is 2x minus 5. So when you plug f, or, oh, sorry. So when you plug the f function into the g function, then f of x, whatever f of x is equal to, is going to replace the x in that current problem. So we take 3x plus 4, since that's what f is equal to. We plug that in for x. And then all I have to do is simplify. So all I did was I distributed the 2 out in front. That became 6x plus 8 minus 5. And then combine like terms. 8 minus 5 ends up being positive 3. So final answer is of g of f of x is 6x plus 3. Okay. So for example 10, basically we're going to do the same thing. We just do it with actual numbers. Here, we're going to take g of negative 3 and plug it into f. So all I did first was find g of negative 3. Plugged in negative 3, plug that into my g function. And simplifying, you get negative 11. So if that's what g of 3 equals, then whatever g of 3 equals gets plugged in for x in the f function. So f is 3x plus 4. We plug that negative 11 in for x. And we simplify to get g of f of 3, or f of g of negative 3 equals a negative 29. So at the bottom of your page right now, there are some extra problems if you want to go ahead and try them. But if you're feeling pretty good, then you can move on and you can start working on the homework now.